There's your thought for the day. We're going to cover section 4.5 first today. It's prove triangles are congruent by angle, side angle, and angle, angle, side. Our objectives for 4.5 is to do that. Prove they're congruent by angle, side angle, and angle, angle, side. So far the shortcuts we have are side, 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 angle, side, and hypotenuse length. We're going to add to that list angle, angle, side, and angle, side, angle. Angle, side, angle says that two angles and the included side of one triangle are congruent to the two angles and the included side of a second triangle. The two triangles are congruent. With side, angle, side, we talked about an included angle. Now we're talking about an included side. I've got two angles. In between them is a side that is congruent to a side in the other triangle. So that's when they're talking about the included side. So this would be angle, side, angle, as marked. You can see, let me mark it a little darker. Those are my congruent angles, and there's my congruent side. So I name these by either going clockwise or counterclockwise around the shape. So you find where an angle starts. And I know this is going to be angle, side, angle because you can't, as you go around and you're naming which shortcut it is, you cannot skip you can't skip two parts. So if I went this way and I did angle around this way and then I came to this other angle and then the side and might want to call this angle, angle, side, I know I can't do it because I start with angle, I skip a side, and then I skip an angle. I can't skip two parts. So the only way I can go is this way. This way I don't skip anything. I go angle, side, angle. So these two triangles will be congruent by angle, side, angle. And again, make sure you get the vertices that correspond to each other in the correct order when you name them. A has two hash marks. D has two hash marks. Those two go together. And so on. All right? Angle, angle, side looks like this. So I have, on this one, I have an angle, a second angle, and a side. And they match up with the other triangle. This one, it's easier to go the wrong way around. If I started at C and went towards B, I have an angle, I skip a side, and I skip an angle. I can't skip two parts. If I did, I could call this angle, side, angle, but it's not because as I go counterclockwise, I skip a side and I skip an angle. If I go clockwise, I go angle, skip a side, I can skip one part, and then we have an angle. That's the way I want to go. I don't skip two or more. So I go angle. This is called angle, angle, side. Everybody get what I'm saying as far as naming which shortcut you're using? Going clockwise or counterclockwise, and how many parts you can skip and all that. Any questions about that? Again, when we name these two, you've got to get the vertices that correspond. A has two hash marks, so D's going to have, and D has two hash marks, so those two would be the first letters. I started with A, so I'd start with D over here, and so forth, to name the triangles. Let's do some practice. Decide if you have enough information to say the triangles are congruent or not. If they are congruent, we're going to write a congruence statement. When it says write a congruence statement, that means write which triangle is congruent to which triangle. Well, a lot of times people see that on a quiz and they don't know what that means. It's just saying triangle ABC is congruent to triangle DEF or whatever. That's your congruent statement. Your reason or your shortcut is answering the question, how do you know? So in this first picture, the D got cut off there. This is D. Are these two triangles congruent, and how do we know? Okay, they both have right angles. Yes.
They're congruent because the hypotenuse and one leg are congruent.
Yes, they are congruent by hypotenuse, leg. Anytime you have a right triangle, that should clue you in. Oh, I got to test to see if it works for hypotenuse, leg. Sometimes it'll be side. If it's two legs and an angle, in the right angle, it might be side, angle, side. But most of the time, if it's a right triangle, it's going to be a hypotenuse, leg. Trent, can you name the make the congruent statement?
Triangle CAB is congruent to triangle FDE.
All right, triangle CAB is congruent to triangle FDE. That works, and that's by hypotenuse, leg. All right. Now, before we go on, because we want to make sure that these don't fall in that category, I want to talk about what we cannot use shortcuts for. I cannot use side-side angle, or we can reverse that, angle side-side. That tells you can't use it, right? Because I wouldn't want you to write that on a test. But side-side angle is not a shortcut, and angle is not a shortcut. Those would not work. All right? Side-side angle would look like, be marked something like that. As I go around, I have a side, skip an angle, side, angle, side, angle. That's that. If I had another triangle that looked like that, I could not say they are congruent. That is not a shortcut. It doesn't work. And if we can't go around this way and make it side, angle, side because I skip two parts. I skip an angle and I skip a side. So side angle doesn't work. And then if you have a triangle marked like that, with three angles congruent to three angles in another triangle, that doesn't work. They're similar, which we'll do in a later chapter, but they're not congruent. So these two are not shortcuts. Let's take a look at number 2. Are we able to say those are congruent, and if so, why? So start at one of the congruent marked parts and go around either clockwise and counterclockwise and see if you have one of the combinations. That's how you do it. You got to start somewhere, so pick one of the congruent parts and go around clockwise and counterclockwise and see if it meets one of our shortcuts. Right? Yes. If we start at T, we go, there's an angle at T, we skip a side, then we got an angle at S, so that's angle, and then the next part is the side. As we go around T, TSR, counterclockwise. So it's angle, side. Name give us the congruent statement, Ryan.
Triangle TSR is congruent to LMN.
All right, triangle TSR is congruent to triangle LMN. And that's by angle, side, right? All right, what about number 5? Are they congruent, and why? Lindy?
Would it be angle
Yes. Angle, side, angle. Everybody see that? The angle, side, angle? Okay, so give us a congruent statement, Lindy.
Triangle ECD is congruent to triangle GFH by ASA.
Triangle ECD is congruent to triangle. Okay, if I start with E on the first one, I would have G matches up. Is that what you said?
Yeah.
Okay, triangle GFH. Yeah, triangle GFH. And that's by angle, side, angle. Let's go to number 3. Yes.
Triangle TSV is congruent to triangle TUV
By.
angle side.
I don't have any angles marked, so it wouldn't be angle side.
Side.
Yeah, side, because always remember when you have a shared side, you're going to mark it congruent to itself. So TV is congruent to itself. So it's common to both triangles, and so we have that's a side congruence. Number 6. How would I say those triangles are congruent? You have to mark an additional part, I'll tell you that much. Lindy?
Would that one be side angle side?
Yes, it would. And because of the what parts are congruent, what do we call them? We have what here? What do we have in these two? Yeah, we have vertical angles. The vertical angles are congruent. So we could say triangle FDE is congruent to triangle JDK by side angle side. Now, make sure on these problems like this where you have triangles joined by vertical angles that you name them. The E goes with the K. A common mistake is people just do it like a mirror image and say DEF is congruent to DJK, where they have the E and the J in the same position. But they aren't the ones that are congruent. It's the ones on the opposite side. So make sure you have that straight. Don't do the mirror image. Make sure you go to the other side to get your congruent part. All right, the last one. We've got some parallel lines there. What should we mark first, though, before we do the parallel lines? Yes?
Angles.
Well, yeah, we're going to do angles, but before that, what do we have? We have a shared side. We want to mark that first, right? Yeah, XZ is congruent to itself. Always do those first so we don't overlook them. Now, with the parallel lines, what does that do for me? What can I use? We've got parallel lines. Okay, this line XZ is a transversal. Now do you see what type of angle pairs can we say are congruent? We've got alternate interior angles. We can say that this angle, because of these two lines being parallel, because of XY being parallel to WZ, we can say the alternate interior angles are congruent. These two are congruent. And then, because of these two lines being parallel, we can say that, let's do them in a different color, it's getting kind of confusing. Let's say that, we can say that these two angles are congruent from these parallel lines. All right? So now, what's my congruence shortcut? Which congruent shortcut enables me to say the two triangles are congruent? Yes?
Angle, side, angle.
Yes, it's angle, side, angle. This side, and that angle. Angle, side, angle. So we could say they're angle, side, angle. Give us the congruent statement, Ellen.
Triangle XZW is congruent to triangle VXY.
Yes. XZW is congruent to ZXY by,
Yes.
yeah, ASA. All right. Questions on that page? All right, you're going to see these type of problems on the quiz. You're going to see them on the test. So make sure you understand it. Go back through it, practice it, and be able to identify congruent statements and shortcuts. Here's some more to look at. In the pictures, you have these pictures in your notes, or is it just up here on the screen? They're in your notes? Okay. Then how can I, before I check for congruence on this, I can mark something else congruent in these figures. What else would I mark congruent about Y? What do we have, Allie?
Vertical.
Right, we've got vertical angles. This angle and this angle are congruent by VA. So now how can I say those two triangles are congruent? What's our reason? Okay, Allie? Yes. Angle, angle, side. So those are congruent by angle, angle, side. What about B? Can I say those triangles are congruent? Why not? I've got three angles in one marked congruent to three angles in the other.
You don't have the lengths.
Yeah, that's not one of my shortcuts. Angle, angle, angle is not a shortcut. So this is no. What about the last one? What do we have on the last one? Yes.
Angle, side, angle.
Yes, because we have the shared side in the middle. So we have the angle, side, angle congruence. Yes. Yeah, I'm going to give you guys a break in a few minutes when we finish this section of notes. Well, I'll give you guys a break. All right. Flow proof. Okay, a flow proof is uses arrows to show the flow of a logical argument. Each reason is written below the statement and justified. So flow proof is one more step further in organizing a proof than a two-column proof or a statement reason proof, because it tells you, it connects the statements that lead to another statement are connected to it by arrows. You'll see what I mean when I put this next flow proof up. Do I have that definition? All right, so here you can see we're going to prove the angle side theorem, so we can't use angle side in our proof. We've got our given, we've got our proof. What we have to prove? We have to prove the triangles are congruent. So the first thing we have to do, we've got two boxes with the reason is given as the reason for both the boxes. We've got to figure out which of these two givens. Well, one of them is already used, CF congruent to C congruent to F. We eliminate that one. We've got to figure out with which one A congruent to D and BC congruent to F, which one goes in this box. So then you got to look ahead. The arrow C congruent to F and that the empty box those two statements go together to be able to make us say that B is congruent to E. All right? So let's think about, okay, B and E are not marked congruent in the figure. But we know that C and F are congruent. And as we have it marked in the figure, A and D are congruent. Right? What would be able to make us say that B is congruent to E?
If you put line BC is congruent to line EF in the first box.
Yeah? No, you don't do that. I thought you said if. No, you don't do that. What do we have? What rule do we have? It says these two are congruent, so we know B and E are congruent. Anybody remember the rule? Yeah. Third angle theorem, right. So we can write that as a reason for B and E. It's the third angle theorem, which says if two angles of a triangle are congruent, we know the third angles of the triangle are congruent. So to be able to use the third angle theorem, what has to be in this box? The angles, right? Angle A congruent to angle D. So we're using logic here. Flow proofs are logical. These two statements, A congruent to D and C congruent to F, enable me to say, as shown by these arrows, that B is congruent to E, and that's by the third angle theorem. So we know that if that given goes there, then this other given has to be B, C congruent to EF down at the bottom. And then we've got, so this congruent statement, A, B, C congruent to D, E, F, what it leads us to be able to say that is, we've got, we'll mark them in green here. We've got B congruent to E, that's shown from this arrow. And then we have C congruent to F, from that arrow, and then BC congruent to EF, that arrow. Those three things, as I marked them in the figure, enable us to say the triangles are congruent. What reason is that? Look at how we've marked the triangles. What reason is that? Megan. Eva. All right, start at one of the congruently marked parts. Start at B. Let's go counterclockwise. We go start at B, we go this way, we skip a side, we skip an angle because this one's not marked in green. All right, so that we can't go that way, so we go this way. Angle, side, angle. I go clockwise. I've got an angle-side-angle relationship. Shortcut there. So that's angle, side, angle is the reason for why those triangles are congruent. Yes?
Wait, so it's angle side angle because there's not a marking between B and A and C. So that's not why we were marking.
Right. Because, yeah, they aren't marked. Right. There are other shortcuts we could apply to this theorem and prove it. From using what they have the arrows drawing from, we have to use angle, side, angle. We could also say these triangles are congruent by angle, angle, side, but that's not what the proof showed. All right. This one's challenging. Let's try this one. In the diagram, we've got CE perpendicular to BD. So let's mark that. CE perpendicular to BD. And we have CAB congruent to CAD. I moved it. We have those two angles congruent. And we have to prove these smaller triangles on the bottom, AEB and AED, we have to prove they're congruent. So let's see how the flow proof, what information it gives us. We've got BAE and CAB are supplements. And then we've got DAE and DAC are supplements. How do we know they are supplements? What are these? What is this pair of angles and this pair of angles? We have a name for those pairs. What are they? What pair of angles are supplementary? What are those called? They make, yeah.
Linear pair?
Yes, those are a linear pair. So we can put linear pair as our reason for why those are we know those are supplements.
There's two more.
Yes?
On here it says the reason is definition of supplementary angles.
Oh, they already got the reason written in?
Yeah.
I'm gonna go with linear pair.
Okay.
All right. They are supplementary, but how do we know they're supplementary? Because they're a linear pair. I would accept either one there. All right, now so now we're going to use that in another statement to say that BAE, angle BAE, and angle DAE are congruent. Which one of those two givens do you think is going to go in that box? This box right here that has an arrow drawn to what I just talked about. Yes.
Angle CIB is congruent to angle CID.
Yes. Angle. So we're going to add angle CAB is congruent to angle CAD. And that was given. That leads us to be able to say, let's mark this now in red, that enables us to say that BAE is congruent to DAE. Those two are congruent. Does anybody remember the rule? It involves supplements and congruent angles. What is the rule?
Congruent supplementary.
Yeah, and what does that say? More importantly, what does it say? Okay, the rule says supplements of congruent angles are congruent. So BAE and DAE are supplements of these two angles are the congruent ones. BAE is supplementary to the first one. DAE is congruent, supplementary to CAD. So supplements, these are supplements of congruent angles, so they're congruent. So that would be our reason. And you can just write it as sup congruent angles congruent, just like that. If you don't remember the name, that's the congruent supplements theorem. But I'd rather, more importantly, I need to know the idea. If you remember the idea, just write the idea, and you can abbreviate it with symbols. So that's that part of the proof. Then we've got, this is our other given. We've only got one other choice there. That's going to be CE perpendicular to BD. That's given. And so from that we know that AED and AEB are right angles, because perpendicular lines form four right angles. And then we know that those two angles are congruent, so we can mark that in the figure. These two are congruent because of the right angle congruence theorem that says, or you can just write all right angles congruent. That's what that says. All right angles are congruent. So we've got two parts. It's getting kind of cluttered. Let me clear that out and remark it. We've got these two angles congruent and these two angles congruent. What do you think I'm going to say by reflexive property? We're trying to show that this triangle is congruent to that. What would reflect something equal itself? What equals itself in those two triangles? Megan, what equals itself? Not sure? Eva? Okay, Kayla?
ABE, DEF.
We don't know that. Lindy?
CE.
CD? Well, but we're talking about the smaller triangles.
Oh, AE.
Yeah, we want to say AE is congruent to AE. AE is congruent to AE by reflexive property. So now we've got this line congruent to itself. So how are these two triangles congruent? Well, the triangles are congruent by what you have to prove is always going to be your the result of your proof, and it shows ABE is congruent to ADE. That's what's going to go in. That's by angle side angle. So we would have triangle ABE congruent to triangle ADE. All right, that's about as complex as a flow proof that you will have to do. I can't see you doing anything more difficult than that one. That's a challenging proof. All right, any questions? That's it.